Let's now learn about higher derivatives, in particular, how they're notated, what they can represent physically, and how their graphs are related. Higher derivatives of a function are just derivatives of derivatives. They tell you how a function's rates of change keep changing. A function is often notated as y or f of x. Its first derivative is going to be notated by y prime, or you might see it notated as f prime of x, or what we call df dx. A second derivative is notated as y double prime, or f double prime, or d squared f dx squared. And then lastly, a third derivative is notated by y triple prime, or f triple prime of x, or d cubed f dx cubed. A function can also represent the position of an object and be notated as s of t. Velocity is the instantaneous rate of change of position with respect to time and is notated typically as v of t or ds dt. This could also be written as s prime of t. Then we have acceleration, which is the instantaneous rate of change of velocity with respect to time. It's usually written as a of t or d squared s dt squared or v prime of t or dv dt. And then lastly, we have a term called jerk. It is the derivative of the acceleration function, and it is written as j of t or d cubed s dt cubed, or more commonly, just dA dt. Let's now look at an example where we have a figure that shows the graphs of f, f prime, and f double prime, but we're not told which one is which. Our job is to identify each curve. When I teach calculus, my students usually find this problem to be a little challenging, but we'll walk through it really carefully so you'll know exactly what to do. One good way to start a problem like this is to look at where each graph has a slope of 0. Our blue graph has a slope of 0 here, and then our red and green graphs also have a slope of 0 there. Because all these graphs have a slope of 0, that's not really going to help us identify which curve is which. Let's see where else these curves have a slope of 0. The red curve has a slope of 0 here, and then the green curve has a slope of 0 here and about here. Wherever a graph has a slope of 0, its derivative is going to be 0. Notice that there is a 0 right here that corresponds to our red graph having a slope of 0. This means that the green graph is the derivative of the red graph. Let's look again at the green graph. There is no 0 point here or here that corresponds to where the green graph has a slope of 0. So that means that the blue graph is not the derivative of the green graph. Let's now look back up at the blue graph. Notice that the blue graph has a positive slope all the time. That means its derivative has to always be above the x-axis. Notice that our red graph is always above the x-axis. So the red graph must be the derivative of the blue graph. We can now identify the curves. Our blue graph is going to be f. Our red graph is going to be f prime, and then our green graph is the derivative of the red graph, and it is f double prime.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.